Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. We are from Group 2 Section 3 want to present about fiber reinforced concrete. Now, I want to introduce the presenter for this presentation. First, my name is Amirul Effendi Azmi. Hanif Naufal bin Muhammad Hassan. Asfarina Shafiqah binti Azhari. And lastly, Arnold bin Asli.
FRC can define as a composite material consisting of mixtures of cement, mortar, or concrete and discontinuous, discrete, uniformly dispersed suitable fibers. FRC are of different types and properties with many advantages. Continuous meshes, woven fabrics, and long wires or roots are not considered to be discrete fibers. Fiber is a small piece of FRC material possessing certain characteristic properties. They can be circular or flat. The fiber is often described by a convenient parameter called aspect ratio. The aspect ratio of the fiber is the ratio of its length to its diameter. The typical aspect ratio range from 30 to 150. FRC is concrete containing fibrous material which increases its structural integrity. It contains short discrete fibers that are uniformly distributed and randomly oriented. FRC include steel fibers, glass fibers, synthetic fibers, and natural fibers. Within these different fibers, the character of fibers concrete changes with varying concretes, fiber materials, geometries, distribution, orientation, and densities. FRC is mainly used in shotcrete but can also be used in normal concrete. Thank you, that's all.
Now, I want to explain about material properties. First, we have physical or mechanical properties. In fiber reinforced concrete, steel fiber have the special ability to have various forms such as crimp and hook ends, which can help strengthen and binding between the concrete and fiber. With a high yield of strength, structural reinforcing rebar such as syrup replaced to help reinforcement congestion and encourage the use of concrete in smaller locations where a large syrup will be difficult to fit. Next, I will explain about the chemical properties of fiber reinforced concrete. This is due to the type of glass used degrading when exposed to highly alkaline concrete matrix. Fiberglass does not corrode when used in concrete, unlike steel fiber. Next slide. Now, I want to explain more about process or procedure. First one, we have material manufacturing process. This is one of the process is hand layup spray up. Example of CFRP, manufacturing process that are not automated. The second one is process of material application. The use of fiber reinforced concrete depends on how well the builder and applicator take advantage of the material's static and dynamic properties. Such an example, runway, aircraft, parking, pavement, tunnel lining, slope, stabilization, tin shell, wall, pipes, manhole, dam, hydraulic structure, elevated, and lastly deck. The third one is the procedure. A common test procedure for fiber reinforced concrete flexural toughness and initial crack strength is ASTM C1018. The ASTM C1550 test employs a centrally locked circular panel to measure the flexural toughness of fiber reinforced concrete.
Assalamualaikum. Hi, I'm Hanif Naufal bin Muhammad Hassan. I will tell about a discussion and uses. Have more benefit for sustainable construction. For example, the energy delivery from the post displacement relationship can include energy absorbed during the non-linear behavior of a conflict in compression in addition to the energy loss. So, conflict breaking. Thus, deflation occur in ductile material, such as a concrete reinforced with aluminium fiber, before they run out of power to absorb. In this situation, it's possible that the fixed point of the bar support the displacement transducer wanna stay fit, causing an additional deflation in the control displacement transducer and resulting in an inaccurate assessment of the fracture energy. In the current, these variables are examined to determine whether the specimen dimension and test method are appropriate for determine the fracture energy of cell. After that, the crack arcs machine for FRC is similar to how aggregate failure absorb energy and are known to as micro cracks in a concrete. It appears, however, that benefit attributable to fiber occur to the brittle matrix in amounts ascending that which is predicted by the law of mixture. In addition to fiber strength and elastic properties, improved fiber efficiency is related to bond anchorage and the potential for energy absorption to the accumulate effect of the number of fibers, their specific surface and their orientation within the matrix. This relate to comprehensive treatment covering the basic theory, properties, production, and application of various fiber, cement, and concrete types. Finally, our suggestion for the future is to show how useful it is to put the energy concept from the previous discussion into practice. Although the section and application is not meant to be exhaustive. The discussion is divided into fiber refers part cement concrete composite technology. They have a machine testing and implementing and evaluation and value add application. The breadth of formulation and application of FRC explain that considering either the machine of behavior or the performance of FRC in a strict generation. Science fiber in concrete is an unproductive overseen amplification.
Conclusion or summary, I will tell about FRC. FRC has been growing in popularity for several decades now, with scientists and engineers are still looking for the perfect fiber. Contractors already have a choice between various types of fibers to suit their specific applications. Being able to offer FRC concrete to your clients increase the range of construction projects your company can bid for it. Granted, FRC tends to be about 10 until 15% more costly than traditional concrete, but the benefits gained from its longevity more than make up for the increased its cost. Adding the FRC to your volumetric measure is an excellent investment in the future of your business. FRC concrete helps control cracking, which is likely to occur due to plastic and drying shrinkage. That is one of the reasons behind its growing popularity. Subject to the type of fiber chosen for the compound, it can increase toughness 10 to 15 times. Thank you.
Now we go to the reference part. There are 5 references that we get from the article. Concrete ACI 544.1R96 ACI Manual of Concrete Practice Part 5 ACI International Farmington Mills 1997. Second is JAO Barrels Jessina Cruz Fracture Energy of Steel Fiber Reinforced Concrete page 29 until 45 2010. Thirdly is from Osman Jensel, Vitor Brustow, T. Datashvili, and Michael Tediot. Workability and mechanical performance of steel fiber reinforced self-compacting concrete with fly ash, page 169 until 184, 2012. And the number 4 of the reference is from Ronald F. Zolo, Fiber Reinforced Concrete, an overview after 30 years of development, received 16 November 1995, except 21 October 1996. And the last reference is from Fausto Minelli, Giovanni Aplizzari, in Brittle Matrix Composites 9, 2009. Thank you from me.
Now I can tell about our group appendices. Our group have three appendices. For the number one, a fiber reinforced concrete. Second, ASTM C1018 fiber reinforced concrete flexural tools equipment. And the last one, ASTM C1399 residual straight fiber reinforced concrete first equipment. This all about our group appendices. That's all from me, and thank you.